Hi friends, welcome to GMK tutorials. In this video, we are going to see the how synchronous counter is going to be perform the counting operation, which may be either up counting or maybe down counting. So that the complete circuit can be represented with the help of a single diagram. Obviously, in case if you have any doubts related to this one, please watch the synchronous counter video in our channel also. Okay, let us see. Just I will give the brief introduction about this one, then we will go for the programming. So let us see here. The synchronous counter operation can be designed with the help of a T flip-flops. So here T flip-flop T0 is the first flip-flop, T1 and T2. These are the three flip-flops. Where M is used for controlling purpose. That means based on the M value, if you are taking M is equal 0, which performs up counting, and M is equal to 1, which performs the down counter. So that is the basic scenario. Suppose let us see here, when M is equal 0, what happened? This is a line, right? So M is equal 0 means that this is a complemented version. Then it is given to the AND gate, as well as when the logic 1 is equal to 1 means that only T flip-flop is on for only 1. At that time only it performs the toggle operation. So based on the button, which one selects the, so Q0 is the output of the first T flip-flop, Q1 is the output of the second flip-flop, and Q2 is the output of the third flip-flop. So based on this M1, first if you are taking M is equal 0 means that obviously M bar is equal to 1, therefore the X1 is the output is high. So it may be 0 or 1. So this is activated. Then based on this one, it is given for the next flip-flop input based on the XOR gate, as well as that means based on this one, either of the only one gate is activated. Suppose if you are taking M is equal 0, M bar is equal 1, therefore X1 gate, that means first gate is in active condition, second gate is in half condition. So that is nothing but, moreover, if you have any idea about the synchronous counter in case of the flip-flops also, the counting operation based on the Q and Q bar values. If you are taking Q is the output of the, that means output of the only direct output if you are taking from the flip-flop, which performs the up counting operation. Otherwise, if you are taking the complement of the output, then it will performs the down counting operation. So then only we can conclude this one. So these are the possible representation when T1 is equal to, so y1 output, like if your T1 is input for the second flip-flop, right? So therefore y1 is equal to, what is the possible combination from this diagram? First one, M bar, complement of M bar and Q naught, both are connected to the AND operation. Therefore this is the product term, plus because of your given to the OR gate, for the purpose plus M into Q naught bar, so for X2 purpose. So these two are connected to the OR gate. That's why we can perform that. As well as T2 input is also same thing, X3 and X4. This is a combination. Totally you can represent T1 and T2. So let us see the programming point of view. So basically, just, so this is the code for a module program. Module program is nothing but designing program here. Module is a keyword for Verilog program. Synchronous counter, I have to represent the synchronous counter module name with a synchronous counter. Then I will take the sum of the outputs. So Q is the output for the T flip-flop, clock is for synchronization, M is the controlling input, reset is the reset is a reset pin for the counter. So let us see output 2 down to 0. So Q is the output, because of in case of T flip-flop output can be represented as a Q, right, in the diagram itself. So in the diagram we can represent Q is equal to output Q0 and Q1. So because of we are using a 3 flip-flops, so 3 flip-flop outputs can be represented in terms of a 3 combination. So that's why it can be taken as a Q0, Q1, Q2. So for that purpose 2 down to 0. As well as from this diagram also, so as well as in this diagram also, let us see the possibilities. Like input clock M reset at the same time. So input clock is nothing but we are using a synchronous counters. So synchronous counter means the clock is applied for all flip-flops at a time. So let us see here also. So the clock signal is applied for all the flip-flops at a time. Therefore, this is generally called as a synchronous counter, means that the all flip-flops clock is activated at a time. As well as this is nothing but reset pin. Reset pin is used for In case if you want to reset the counting operation, obviously it will goes to the initial state. So for that purpose, the counting operation. So reset is also used for this one. So let us see here the remaining statements. Input is clock M reset, and that means this is generally called as a port list. Okay, you can also call as a input output port list. So port list means what are the input and output combinations are present in the synchronous counter. Okay, then that input output variables, how you are going to use in case of your program. Now use చేసిన input output variables మీ program లో ఎలా యూస్ చేస్తున్నారు, that can be specified with the help of a input గా ఏ variables యూస్ చేస్తున్నాం class. Okay, then byte is nothing but in case of the diagram we have some numbers is there like x1, x2, x3 and x4, y1, y2. So these are the intermediate outputs. These are the intermediate outputs. These intermediate output means that for the intermediate outputs can be represented with wire gate, wire. So x1, x2, y1, y3, x4, y1 and okay. So these are the possible conditions. So based on that one, so for that intermediate outputs can be represented x1, x2, y1, y2, x3 and x4. That means just I will represent x1, x2 is the input that is connected to y1 is our gate purpose. So for that purpose, just I will give the numbers. In case if you want to represent x1, x2, x3, x4 also, not an issue also. Okay, wire input is equal 1. That means any flip flop. That means in case of the t flip flop is working only when t is equal to 1. When t is equal to 1 only, it performs a toggle operation, otherwise it acts as a memory state. So for that purpose, in order to provide input for the counting operation, just I will mention input variable as a in. Okay, then let us see the this is a structural representation. So let us see the diagram first, then we will get some so this is the AND gate output where x1 is equal to output of the AND gate. So what are the input for AND gate? Q naught. This is connected to the NOT of the gate, therefore M bar. Okay, so then from this line we can represent the AND gate, and A1 is for instantaneous UVT name, AND gate. So AND is a keyword, it is a predefined keyword. It is also called as the AND gate primitive. So gate primitives and good antam. E AND and for use saying on a keyword only, which performs the AND operation based on the input variables and produces the output in the అవుట్పుట్ వేరియబుల్. సో AND గేట్ మనం ఏం చేస్తాం, x1 అనేది మన అవుట్పుట్ వేరియబుల్ గా కన్సిడర్ చేస్తే కదా, ఈ x1 వేరియబుల్ కి ఇన్పుట్స్ ఏమి ఇస్తున్నాం, Q0 అంటే ఫస్ట్ ఫ్లిప్ ఫ్లాప్ యొక్క ఇన్పుట్ ని అసలు M బార్ అంటే కాంప్లిమెంట్ ఆఫ్ ది M ని తీసుకొని ఇన్పుట్ గా ప్రొవైడ్ చేస్తున్నాం, అవుట్పుట్ మనం x1 అని తీసుకున్నాం. సో దట్ ఈస్ అ రిప్రజెంటేషన్ ఆఫ్ దిస్ స్టేట్మెంట్ లైన్. Come to the AND gate also. So you can observe in the gate AND gate. So because of I will use the A1, A2 for representation. A and AND gate and assumption this any variable. In case if you need B or C, whatever it will be, it is not an issue also. So let us see here Q0 bar. So Q0 bar and M are the two inputs for the second AND gate. So let us see here in the diagram. So x2 is the output for the second gate. Okay, so this gate connected to the M line directly, first line, therefore M and Q0 bar. So complement of the Q0. So these two are the input for AND gate. So for that purpose, I can represent the M and not of Q0. So complement of the Q0 is nothing but not of Q0. Therefore, అందుకే నాట్ సింబల్స్ యూజ్ చేస్తుంది. దాని అవుట్పుట్ ని మనం x2 గాను. సో x1 x2 దేనికి ఇస్తున్నాం, ఆల్రెడీ ఆర్ గేట్ కి ఇస్తున్నాం కాబట్టి జస్ట్ ఐ విల్ మెన్షన్ ఆర్ గేట్. దీని O1 అజంప్షన్ తీసుకున్నా, అవుట్పుట్ ఆఫ్ ది ఆర్ గేట్ కెన్ బి డిక్లేర్ as y1 అని తీసుకున్నా, x1 x2 గా ఇన్పుట్ యాక్ట్ చేస్తున్నా అని చెప్పి. Then coming to the AND3, AND gate కూడా AND3 కి inputs provide చేస్తున్నాం. Let us see in the diagram itself. So AND3 gate కి యూజ్ చేస్తున్నాం, గేట్ AND3, this is third gate, this is the fourth gate. So for the x3 output, input వచ్చేసి ఒకటి x1 and second one is like q1. At the same time x4 ki q1 bar and the second one is nothing but x2. So from this diagram you can write the AND gate A3 is equal to x3, q1, x1 and 4 ki aithe x4 and assumption తీసుకొని not of q1 and x2. This is very simple code guys. If you are understanding the logic of the diagram, just you can blindly write the code with the help of a structural coding. It is too easy for you in case if you know the concept of this one. The last gate is nothing but OR gate. The OR gate declaration for that purpose UVT name is equal to O2 assumption తీసుకున్నా y2. So what is the output of what is the output for OR gate? So from this diagram y2 output is y2 is the output for the OR gate. Inputs are x3 x4. Therefore x3 x4 are the input, x3 and x4 are the input for OR gate, then output can be treated as a y2. So this is enough. This complete coding can be given a complete coding ఈ diagram complete code code రాస్తాం. But ఇక్కడ T flip flop యూస్ చేస్తున్నాం. ఈ T flip flop వర్క్ అవ్వాలంటే obviously you have to provide the T flip flop code. ఆల్రెడీ మనం ప్రీవియస్ వీడియో చూస్తుంటారు. T flip flop కోడ్ వచ్చేసి మనం మెన్షన్ చేస్తున్నాం. సో ఇన్స్టాంటేషన్లీ T flip flop నేను అంటే ఆల్రెడీ నేను ఈ మాడ్యూల్ నేమ్తో T flip flop కి కోడ్ రాస్తున్నాను. సో ఫర్ దట్ పర్పస్ TFF అని రాసుకున్నా. TFF0 అంటే ఫస్ట్ ఫ్లిప్ ఫ్లాప్. సో T flip flop అవుట్పుట్స్ ఏంటంటే Q0 is Q0 is the output of the first flip flop. క్లాక్ తీసుకున్నాం. ఇన్పుట్ ఫస్ట్ వన్ కి ఇవ్వాలి, రిమైనింగ్ అంతా ఆటోమేటికల్ బేస్డ్ ఆన్ ది ఇన్పుట్ ని బేస్ చేసుకుని ప్రొడ్యూస్ చేస్తుంది ఇన్పుట్ రీసెట్. సో ప్రతి ఫ్లిప్ ఫ్లాప్ కి రీసెట్ ఉంటుంది, క్లాక్ ఉంటుంది, అవుట్పుట్ ఉంది. ఇన్పుట్ ఫస్ట్ వన్ కే ఉంటుంది, రిమైనింగ్ సెకండ్ ఇన్పుట్ వచ్చేసి ఇట్ డిపెండ్స్ ఆన్ ది y1 output. So therefore, so from this diagram, TFF Q0 clock in please guys, you have to observe carefully, then only it easy for yours. TFF is a model name. This is for second flip flop. Q1 is the output of the second flip flop clock. ఇక్కడ ఇన్పుట్ 1 ఇచ్చేసాం డైరెక్ట్. ఇక్కడ y1 అంటే ఏంటంటే ఫస్ట్ ఫ్లిప్ ఫ్లాప్ నుంచి వచ్చినటువంటి అండ్ ఆపరేషన్స్ లో వచ్చినటువంటి ఇక్కడ T1 ఇన్పుట్ ఏముంది, T1 కి ఇన్పుట్ y1 ఇస్తుంది. దేర్ఫోర్ అవుట్పుట్ కెన్ బి ట్రీటెడ్ యాస్ ఏ y1 at the same time reset. So Q2 output clock y2 and second third flip flop ఉంది కదా, థర్డ్ ఫ్లిప్ ఫ్లాప్ మనం ఇన్పుట్ ఏమి ఇస్తున్నాం, y2 ఇస్తున్నాం T2 కి. దేర్ఫోర్ ఇన్పుట్ ఆఫ్ ది థర్డ్ ఫ్లిప్ ఫ్లాప్ ఇస్ ఈక్వల్ టు y2. దేర్ఫోర్ ఇన్పుట్ ప్లేస్ లో మనం y2 ని సబ్స్టిట్యూట్ చేస్తున్నాం. సో ఈ కంప్లీట్ కోడ్ వర్క్ అవ్వాలంటే ఈ TFF మాడ్యూల్ కోడ్ కూడా ఇంక్లూడ్ చేయాలి. సో ఫర్ దట్ పర్పస్ ఐ హావ్ టు డిక్లేర్ ద TFF, దట్ ఈస్ నథింగ్ బట్ T flip flop మాడ్యూల్ నేమ్. ఇక్కడ చూడండి మాడ్యూల్ నేమ్ TFF ఇచ్చారు, దానికోసం కంపల్సరీ TFF ఉండాలి. ఇన్ కేస్ ఇఫ్ యు ఆర్ చేంజింగ్ దిస్ మాడ్యూల్ నేమ్ విత్ సమ్ లెటర్ some name, then you have to change the corresponding module name here itself also. It is not a mandatory. మీరు మాడ్యూల్ నేమ్ కంపల్సరీ ఏదైతే ఇస్తారో అదే ఇక్కడ కంపల్సరీ ప్రెసెంట్ అయి ఉండాలి. దట్ ఈస్ వెరీ ఇంపార్టెంట్. సో Q clock T reset. So from this diagram, output these are the port list. How you are going to use this variable? Q can be treated as output variable, and this is also register variable type because of you can use the both input and output point of view. Clock T and reset can be treated as the input. So for that purpose clock T reset ni input గా యూస్ చేస్తున్నాం. పాజిటివ్ ఎడ్జ్ ఆఫ్ ది క్లాక్ కానీ లేదా నెగిటివ్ ఎడ్జ్ ఆఫ్ ది క్లాక్ ప్రెసెంట్ అయితే ఇఫ్ రీసెట్ యాక్టివేషన్ అయితే అవుట్పుట్ వాట్ ఎవర్ ది ప్రీవియస్ అవుట్పుట్ బ్లైండ్లీ విల్ Q output is equal 0 ట్రీట్ చేయి. else if T is equal 0, that means T is equal 0, it acts as a memory అనుకున్నాం. Therefore it maintains a previous value. Q is equal to previous value. If T is equal 1 అంటే T is equal 1 అంటే T is equal 1 అంటే that means it acts as a toggle flip flop. Output of the T flip flop is equal to complement of the Q. So Q కి not before symbol complement అంటే 0 ఉంటే 1 అవుతుంది, 1 ఉంటే 0. So this is a simple code for synchronous counter. Okay, let us see for check the code for this one, synchronous counter. Just I will click here. Just it is easy for me also. This is a synchronous code test bench. Okay, test bench code చూద్దాం ఇక్కడ. So this is the just some of the related lines itself only. It is not an issue. So let us see. Just I will zoom out this one first initially. It will give some clarity for you. So title. In case if you want to write the test bench, first of all you have to specify the file name for the synchronous. No రాసిన మాడ్యూల్ ప్రోగ్రామ్ ఫస్ట్ నీ టెస్ట్ బెంచ్ కి ఇన్ఫార్మ్ చేయాలి. సో నేను ఆల్రెడీ synchronous counter dot p నేను ఇక్కడ చూడండి, మీరు అబ్జర్వ్ చేస్తే ఇదే ఫైల్ నేమ్ ఇచ్చాను ఇక్కడ కూడా. సో synchronous, సో సేమ్ ఫైల్ నేమ్ ని ఇక్కడ కూడా మనం మెన్షన్ చేయాలి. టైమ్ ఈస్ నథింగ్ బట్ మనం డిలే ప్రొడ్యూస్ చేస్తున్న దానికి 1 nanosecond ఇంటూ corresponding delay ఇంటూ ఇన్ టర్మ్స్ ఆఫ్ nanosecond delay. మాడ్యూల్ టెస్ట్ బెంచ్ synchronous counter test bench నేమ్ ఇలా మెన్షన్ చేసుకున్నా. రిజిస్టర్ క్లాక్ m రీసెట్ ఇన్పుట్స్ ఓకే, y 2 down to 0 అవుట్పుట్ గా ట్రీట్ చేస్తున్నా. సో మాడ్యూల్ నేమ్ UUT. సో దిస్ ఇస్ ద బెస్ట్ వే ఆఫ్ రిప్రజెంటేషన్. డాట్ ఆఫ్ Q ఆఫ్ Q లో బెస్ట్ గా రిప్రజెంట్ ఇనిషియల్ బిగిన్. సో ఇన్పుట్స్ ఏముంటాయి కౌంటర్స్ అంటే రీసెట్ ఇస్ ఈక్వల్ 1 అయితే సో ప్రీవియస్ ఎక్కడున్నా కానీ ఆబ్వియస్లీ 0కి వెళ్ళిపోవాలి. ఓకే, సో రీసెట్ 0, m is equal 0. m is equal 0 అంటే ఏం పర్ఫామ్ అవుతుంది, ఆబ్వియస్లీ m 0 అయితే విచ్ పర్ఫార్మ్స్ ది up count of the operation. M is equal to reset 1, again reset 0, m is equal to 0, reset 1. Just I will give you some reset condition based on this one. It may be go for the initial state. So for that purpose I have to give some consideration. Initial clock is equal to 0, always 10, clock is equal to non clock. Okay, so let us see the diagram for this one. Just I will run this code also. will check the behavioral check syntax for the test bench program. Okay, it is also correct, fine, no, not an issue, no issues are there. That's why it can be represented as a green color tick mark మనకు వస్తుంది. Then coming to the mm, simulation, just see here the process is going to be run. Okay, just yeah, fine, we can get the output. Let us see the here. Just I will fit to window, zoom out, zoom in first usually. So this is better somewhat, right? So let us see here, observe some of the observation. Initially, okay, m is equal don't know, so that can be represented as unknown value can be represented x. Reset is an activation condition. Obviously, flip flop is in 0 0 condition. When the positive edge of the clock is 1, okay, clock value high, m value 0. M value 0 and obviously it is nothing but up counting operation. So 0 and 0 nunchi 1 state, 0 1 0 2 3 4 5 6 7. 7 and obviously empty. So it is nothing but we can construct the flip flop with we can construct the counter with the help of a 3 flip flops. So 3 flip flop lo count చేసినట్టే mod of the flip flop is equal to 2 power 3. Therefore 2 power 3 is equal to 8 possible states. So 0 0 నుంచి 1 1 కి కౌంట్ చేస్తే టోటల్ 8 states. 1 2 3 4 5 6 7 8 states. Then counting operation process ఎంత 0 కి వెళ్ళిపోవాలి. So 0 0 కి వెళ్తుంది. Next 0 1 2 3. సో ఇక్కడ అగైన్ సెకండ్ స్టేట్ నుంచి 0 స్టేట్, యాక్చువల్లీ మనకి 7 కి వచ్చిన తర్వాత రీసెట్ 0 కావాలి. బట్ ఇక్కడ there is if you are observe this one, the clock value is 0. okay, clock value is 0 అయింది అంటే the flip flop is not in working condition. That means it acts as a normal. Let us see here, the clock is 1, then the counting process. So in this diagram, so clock is also 0, it is the second condition. Okay, if you are observe this one here 0 1 0 state tarvata, then reset value is equal. When the reset value is high means that whatever the state in the counter, then you will blindly go for the initial state. That's why ఇక్కడ counter state లో reset value high గా ఉంది కాబట్టి then it will go for 0 1 0 తర్వాత then it will go for 0 0 state కి, then 0 1 0, okay, 2 3 4 5 6 7, normal process. Then again come to the same process, 0 నుంచి కౌంట్ చేసుకుంటూ 2 3 4 5 6 7, okay. Then let us see here, reset value high and కాబట్టి again it will go for the reset condition, then 1. So this process is going to be repeated, okay, based on the input conditions. Okay, this is a program for counters. Okay, I hope this video is very clear for you. I think even though if you don't have any knowledge in the this one, then you can get some idea. Okay, just I will change the one value. Let us see, is there any variations. I will treat m is equal to 1 from this. Okay, just I will run the same program again. Okay, just I will save this one. Is there any modifications? Okay, check it, syntax, then simulate the program. Just I will change only m is equal to, okay, based on m value we can have some an idea, right? Just exit this one based on this one. Certain variations. It's in a time being, just we will see. Because of the time constraints only, we can analyze the code. After typing the code only, we can analyze the program. Otherwise, we can see the line by line execution only. Okay, because of the time constraints, we will see the program by before running. After running the code itself only, we can analyze the. Let us see. Just a minute. In case if it is a time taken, then you will go for the next program. Just wait a minute. Because of it is a very easy code guys. In case if you have a basic knowledge related to the topic, obviously it is not an issue. Obviously each and everyone can understand the code as well as the logic behind that one also. Okay, so let us see the because of it is a somewhat time taken, so I don't want to spend much more time here because of we have so many. Okay, so that is nothing but synchronous, guys. Just if you want to write the code for synchronous counter, just if you have no this knowledge, this are a complete circuit knowledge in kundi, and you can blindly write the code for the synchronous counter. Okay, so thank you for watching GMK tutorials. Okay, thank you for your support and all. So please subscribe and share our videos to your friends also. It may be help. It may be help for you. Okay, you can indirectly helps to your others also. Okay, thank you for watching GMK tutorial. Thank you, guys.